So we're back in this video to keep going with our factoring. So next up we're going to do factoring by grouping, and we use this method when we have four terms that do not all share a GCF. And sometimes even if we pull out a GCF, then what we have left we still can factor by grouping. So let's take a look here. If we look at number 14, we can see that if I were to look for a greatest common factor, I could pull 2 out of the first two terms, but not out of the second two. I could pull 5 out of the last two terms, but not the first ones. I could get 3 out of 6 and 15, but not the other two. I could take an X out of some of them, but not all of them. So I don't have a greatest common factor that's in common to all of those terms. But what I'm going to do instead is I'm going to look at these terms two at a time. So I'm just going to look at the first two, and then after that I will look at the second two, including their signs there. And you may notice also that the middle two terms of this four-term polynomial are actually like terms and could be combined. But I'm going to ask you to just believe me for now that we're going to leave them separate. This will actually be part of a process to factor some harder trinomials. So you'll kind of see this is, there'll be a reason why we have two like terms in there. Okay, so factoring by grouping says I'm going to forget about half of the problem for right now. So I'm going to forget about the yellow part. I'm just going to look at this blue part of 2x squared plus 6x. And here I'm going to look for a GCF. So my greatest common factor for these two is 2x. What I have left is x, because I have 2x squared. I took out the 2x, so the 2's cancel. For the x's, I subtract the exponents. Plus 6x divided by 2 is going to be 3x. Sorry, 6x divided by 2x, sorry about that, is going to be 3. So I just pulled out a greatest common factor from those first two. Then I'm going to go to the next two. I'm going to forget that the blue ones even exist. I'm just going to look at the yellow ones there. If there's a negative in front of that yellow section, I'm going to bring it down. In other words, I'm going to pull out a negative greatest common factor. So what I can pull out is a 5. And if I have negative 5x and I pull out a negative 5, that just leaves me with x. And then watch your signs. If I have a negative 15 and I divide out a negative 5, I have plus 3. So I have taken the first two, found a greatest common factor of those, took the second two, found a greatest common factor of those. Now if I look at what I have, if you notice, what I have in parentheses is the same for both terms, which it always should be at this point of factoring by grouping. So in essence, I can think about this being one term, this being another term. What do they have in common? They have that x plus 3 in common. That's like their greatest common factor. And then what do they have left? Well, if I look at this first term and I pull out the x plus 3, then what is left is 2x. And if I take the second term and I pull out or divide out the x plus 3, what I have left is negative 5. Okay, another way of thinking about it is like this. If I have 2x times x plus 3 and I'm dividing out that x plus 3, I'm left with the 2x. And if I have negative 5x plus 3 and I'm dividing out the x plus 3, I'm left with negative 5. So that is what is going to go in the second set of parentheses. And this is my factored form. If I check that, x times 2x is 2x squared, x times negative 5 is negative 5x, 3 times 2x is 6x, and 3 times negative 5 is negative 15. All right, so we can always check that back. So that is how we can factor, that's how we can factor, sorry, I lost my train of thought for a second. That's how we can factor a polynomial that has four terms without any common factor. All right. So let's look at the next one. Now, if we look at the next one, 2x squared plus 6x plus 4x plus 12, this actually does have a greatest common factor. which I don't even know if I meant to have it like that when I made this, but let's pull that out first. So we have 2 times x squared plus 3x plus 2x plus 6. So hopefully this greatest common factor stuff is getting more familiar to you now. So I pull out a 2. There's what I have left. Okay, now again, if I look at what's in my parentheses, there's nothing I can take out of all of them. I cannot take an x out of all of them. And I can't just take it out of 3 instead of 4. I can take a 3 out of 3 and 6, but not the other 2. I can take a 2 out of 2 and 6, but not the other 2. So let's go ahead and do factoring by grouping with whatever's left in parentheses here. I'm going to put an extra bracket just because I need that to kind of keep all the rest together. So I'm going to look at my first 2 terms, x squared plus 3x. So x is my greatest common factor of these two times x plus 3. And then the second group here, it's a positive in front, so that's what I'm going to bring down. I'm going to pull out a positive GCF, 2 times x plus 3, because 2x divided by 2 is x, 6 divided by 2 is 3. Okay, now if I look in here again, I see that, I see that what's in parentheses is the same, right? So I have the same thing in parentheses here. That's going to be one of my factors. So I still have my 2. I have my x plus 3, and then whatever's outside those parentheses is what's going to go in the other factor, because if I have this first term here and I take out the x plus 3, what's left is x. If I have the second term here and I take out the x plus 3, what's left is 2. Okay, so there's my factored form. Now you can multiply this back to check it. Remember, when I have 3 things to multiply, I can do it in any order to check, to multiply back, right? I can do 2 times x plus 3, get an answer, and then multiply by x plus 2, or do the x plus 2 times the x plus 3 first, whatever you would like. Okay, so that factoring by grouping, sometimes we use it on its own, and it's also part of this next type of factoring. So we are talking now about factoring harder trinomials, okay? So what do we mean by harder trinomials? Well, here's my standard form for trinomials, ax squared plus bx plus c. A, b, and c are numbers. This is all like before, but now a is not equal to 1. So what does that mean? Well, I might have something like, oops, actually I don't want an equation, do I? Getting ahead of myself to chapter 10. I might have something like 5x squared plus 3x plus 8. Okay, I'm just making that up. But something that does not have a 1 here for my a. Okay, so remember, this is ax squared plus bx plus c. That's just how I label those. So 5 goes with a. 5 is my a in this case. 3 is my b. And let me change it. 8 is my c. Okay, and the sign goes with it too, right? So it's positive 8, positive 3, positive 5. So let's take a look at this for a minute. Let's start by reviewing some multiplication, as we sometimes do. So 3x plus 1 times x minus 4. So I would do 3x times x and get 3x squared. 3x times negative 4 is negative 12x. 1 times x, and 1 times negative 4. Okay, and then I'm going to combine like terms, so 3x squared minus 11x minus 4. All right, so here's my answer. Again, when I am factoring, I'm starting with this polynomial and working my way back to whatever the factors are that make that, right? So we need to be, those detectives again. So when we look at this, negative 4 did come from positive 1 times negative 4, just like with the easier trinomials, right? 1 times negative 4 gives us negative 4 at the end. However, It used to be that those same two numbers, whatever those two numbers were at the end of the parentheses, those used to multiply to the last number and add to the middle number. Well, 1 times -4 multiplies to -4. It clearly does not add to -11. So why is that? Well, in this case, it's because I don't just multiply. So when I multiply this, I multiply 1 times x, and that gives me 1x. But when I multiply -4 times 3x, in our easier ones, there was never a number there in front of the x. It was just x, right? So -4 times x is -4x. Well, this time, -4 times 3x gives us -12x. So it's a little different. The coefficient of this x is not the same as that last number. So I add -12 and 1, and that gives me my -11. It brings that 3, this 3 out here, it brings that into consideration with this. So that's why these are a little bit different. So how do you know it's a harder trinomial? Well, you know it's a harder trinomial because it has a number other than 1 right here, and no GCF to pull out. Okay, so we saw already that no GCF, or I should say still a not equal to 1, so still a number there after there's a GCF, right? So we already saw sometimes things look messy, but then I pull a GCF out and it's nice. So this is a situation where, but if it still has that 1 in front of it, then we need to do this other method, okay? So if we have a harder trinomial, we're going to use what we call the AC method. So we're going to go through this example on the right-hand side as we go through the steps on the left-hand side. Okay, so the first thing we have to do is multiply A times C. Well, you might be wondering, like, what do you mean A and C? Well, remember, it's AX squared plus BX plus C. So what you might want to do first is write out what A, B, down here, and C are. So A is 4, B is -5, C is -6. So I multiply A times C, 4 times -6, and I get -24. So now I need to find factors of AC that also add to B. So in other words, we want two numbers that multiply to AC and add to B. Okay, very similar to what we did before. Before, our two numbers had to just multiply to C. But this time it's A times C because it takes that first number into account. So in this case, right, in this case, my AC is -24 and my B is -5. So I need two numbers that multiply to -4 add up to -5. So 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. I want them to add up to a negative, so in each case the larger number would have to be negative, and I find that 3 and -8 are my two numbers that would multiply to -24 and add to -5. Now here's where it's a little bit different. Those do not go straight into my binomials, okay? We have another step in here, because if those two numbers went right into the binomial, those two numbers at the end would multiply to -24. It would not go back and look like what I started out with. So here's this little trick. Okay, we're going to take these two numbers, 3 and 8, and we're going to rewrite this trinomial. So I'm going to, instead of 4x squared minus 5x minus 6, I'm going to say, well, 3 minus 8, 3x minus 8x, also means -5x, means the same thing. So I'm going to rewrite it like that. And you might think about this as kind of that format we started out with in the factoring by grouping, where I said that, you know, we have two numbers in the middle that are like terms, we're going to leave them separate. It's because this is sort of the step where that happens. I have 4 terms now. Now I'm going to factor by grouping. Okay, So if I look at this, 4x squared plus 3x, I pull out an x, I have 4x plus 3. Okay, you can take a little time to figure that out. There's a minus here, I pull that out. The greatest common factor between 8 and 6 is 2. Negative 8x divided by negative 2 is 4x. Negative 6 divided by negative 2 is plus 3. You can see that's exactly what I have here, right? I just wanted to show you where it came from. There's actually a typo in here. Sorry, this should be a plus right here. I was not careful with my signs. So I have 4x plus 3 is what's in the parentheses, so that's going to go here. What I have outside the parentheses is x and negative 2, so that's going to go there. And you can check your answer by multiplying. If I multiply this back, 4x plus 3 times x minus 2, 4x times x is 4x squared. 4x times negative 2 is negative 8x, plus 3x minus 6. So 4x squared minus 5x minus 6, and that is what I started out with. Okay, now one thing I want to mention. When we found that the two numbers that would multiply to AC, multiply to negative 24, and add up to negative 5, when we found that those were 3 and negative 8, I put them in, so in this step right here where I'm putting the star, I put those in as plus 3x minus 8x, okay? Now, there's nothing saying that I couldn't put it in the other order like I do down here. Minus 8x plus 3x, they mean the same thing. It's the commutative property of addition. So let's see what happens if I wrote those middle terms backwards. Now notice that my signs are still correct. I still have a negative 8 and a positive 3 because I need that to make my negative 5, no matter what order they're in. So here, 4x squared minus 8x, I'm going to have 4x times x minus 2. For these two, I'm going to pull out a plus 3, and I'm going to have x minus 2. Now, what I have in this step right here might look different than what I have in this step right here, okay? However, if you look at it, really what's happening here is I have the opposite thing in the parentheses and outside the parentheses. Before I had 4x plus 3 in the parentheses and x minus 2 were the outside parts, now it's opposite. So now when I write this, x minus 2 is my common factor here, and I get 4x plus 3. It's the same exact thing as my answer of 4x plus 3 times x minus 2. The order doesn't matter. Okay, so let's go through this next one, and then I just have some sort of wrap-up words for you. Okay, so let's look at this one here. So we have 3x squared minus 11x minus 4. So my A is going to be 3, my B is going to be negative 11, and my C is going to be negative 4. So when I find AC, that's going to be 3 times negative 4, which is negative 12. And my B is going to be negative 11. So I'm looking for two numbers that multiply to negative 12 and add to negative 11. So that part we're pretty much... You guys are pros at that by now, right? So we have 2 and 6, 3 and 4. They have to have different signs from the multiplication, and the addition tells us there are more negatives. Okay, so the larger one in each case is negative. When we look for what they add up to, we can see that 1 and negative 12 are our two numbers that we want. So remember, what we do now is we split this middle term into two numbers. Okay, so 1 minus 12 is the same as negative 11. So now I'm going to factor by grouping. Okay, first we want to look and see, originally there's no GCF. Okay. But all right, so now factor by grouping. X comes out of both of those. We have 3x plus 1. For the next set, I want to bring out a negative. Negative 4 is what comes out of those. 3x plus 1. Always watch those signs when you bring out a negative. It gets a little tricky. So negative 4 times 3x, negative 4 times 1. This is good because at this point I can see that what's in the parentheses is the same. If it's ever the same, almost the same, but has different signs, like one's 3x plus 1, one's 3x minus 1, check your signs of what you pulled out for the GCF and what's left. That's most likely what's going on there. So my factors then are 3x plus 1 times x minus 4. And again, you can check that by multiplying it back. All right, so the last part here, factoring strategies, or how do I know where to begin? Okay, so what you always want to do is the first thing you always want to look for is a greatest common factor, always. And if you can pull out a greatest common factor, go ahead and do that. And we write that like this, where there's the greatest common factor, and then there's a set of parentheses that has whatever's left. Okay. Now, look at the remaining polynomial. So, meaning either after I pull out a GCF, what's left, or if I couldn't pull out a GCF, look at what I have. And we really group these based on how many terms there are. So if there are 2 terms, the only thing we know how to do, once we've taken a GCF out, is the difference of perfect squares. If I don't have the difference of perfect squares, I can't do any factoring. If I do have the difference of perfect squares, it factors into x plus a number and x minus a number. What if it has 3 terms? Is it a trinomial in our form? If so, if a equals 1, then I just find 2 numbers that multiply to c and add to b. If a does not equal 1, I use the AC method. And if there are 4 terms, can I factor by grouping? And then it says repeat step 2 as many times as needed to factor completely. So let's do one of these examples down here. There's a few examples you can do. I think there are just 3 of them, yeah. Let's do number 2 together, okay? So what I'm going to do here is I first look and I see that there's a GCF. So my GCF is 4x. Oops, 4x. So I'm going to pull that out. So I'm going to have 4x times x cubed plus, well, 8 divided by 4 is 2x squared, 9x, and 72 divided by 4 is 18, so minus 18. Okay. So notice that all of the x's in the parentheses, their exponents went down by 1 because I pulled one out here. Okay, so this is like doing that first step. I pulled out the GCF. Now I look at what there is. Well, there are 4 terms, so I'm going to do factoring by grouping. So I bring my 4x with me. Again, I have to kind of have this extra bracket. So these 2, the first 2, have x squared in common, and I'm going to have x plus 2 as what's left. If you need a little more time to figure that out, just pause the video, go back and figure out how we did that. I have a minus in between the 2 groups, so I'm going to bring down a minus, and what they have in common is 9. And I have x plus 2 in common. So here's why I need this extra bracket, because I have this minus, and I need to keep all of this together. Not have the 4x be just multiplied by the first part, but by the whole thing. So then I have 4x times x plus 2 times x squared minus 9. So I factored by grouping. Now, this is where we get here where it says repeat step 2 as many times as needed. I look at what I have and I think about, can I still factor that? So when I look at this x squared minus 9, I can still factor it. It's the difference of perfect squares. So I'm just going to bring this whole thing over here. So I get 4x times x plus 2 times x plus 3 times x minus 3. So as long as there's something to factor, you have to keep going. So this is kind of a complicated example, right? But in this case, we had to pull out a GCF. Then we had to factor by grouping. And finally, we had to factor the difference of perfect squares. So we had 3 kinds of factoring in one problem. Okay, I'm going to just pause the video, do 1 and 3, and I'm just going to show you the answers in just 1 second. So you can pause them and do them on your own. Okay, so here are the answers for number 1 and number 3. The first one we just pull out a GCF. We're left with difference of perfect squares, not too difficult. The next one is an AC method. So I wrote out my A, B, and C. I wrote out what A times C was going to be, so I knew I needed two numbers to multiply 120 and add to 26. When you think of your factors of 120, make sure you write them all out. I'd missed one actually at first. 6 and 20 are the two that do that, so here are my two values here that I wrote, because 20 plus 6 equals 26. Did my factoring by grouping, got my final answer. All right, if you have any questions about these, please let me know.